We are going to explore three important concepts in this particular video, and these will help our junior middle school students to get ahead of senior school students. The three concepts are related to factors of numbers. We'll do prime factorization, and then writing it in the exponent form, we'll be in a position to find the total number of factors. So that is the process which we are going to follow with examples step by step in this particular video. It is part of my book, Inspired by Math, which is for our junior and middle school students. So let's begin with factors. What are factors? Well, if I multiply 5 with 3, I get 15. So 15 is called the product. And these two numbers, 5 and 3, are the factors of 15. So that is the understanding of factors, right? And that is how they are related with the product. When we are talking about factors of a number, we want to list all the factors. For example, in the case of 15, 1 times 15 is also equal to 15. And therefore, we have 1 and 15 also as factors. So we can now write that factors of 15 are what? We can write factors of 15 are 1, 3. I'm writing them in order, right? 3, 5, and 15. So there are 4 factors of 15, which include 1 and the number itself, and 3 and 5. So I hope you got the concept. So we'll take some more examples for our students to understand very clearly. Some numbers have many factors. Okay, so let's take example. For example, 18. Now, how do I write factors of 18? We'll kind of make a rainbow this time. So start with 1. So 1 times 18 is 18, as you know, right? So we kind of connected it. Right? 1 times 18 is 18. You could also divide 18 by 2. So we get 2 times 9 as 18, right? So that is another connection which we made. Okay. We could say, well, 3 times 6 is 18. And that's the third connection which we have made for 18, right? 3 and 6. So we can write that factors of 18 are 1, 2, 3, 6, 9, and 18. 1, 2, 3, 4, 5, 6. It has 6 factors. You get the whole idea, right? Perfect. Let's take a number which is 6. Now, 6 is kind of special. Let's see why it is special. What are factors of 6? 1 times 6 is 6, and 2 times 3 is also 6. And therefore, the factors of 6 are 1, 2, 3, and 6. Now, when we say factors, we list all the numbers, including the number itself, because 1 times that number is giving us the same number. Okay. Now, check what happens if I add these three numbers. If I add 1 plus 2 plus 3, I do get 6 exactly. Do you see that? So, this is a very special number, perfect number, in which these, these are called perfect divisors. In which the only difference is that the number itself is not included. When we say factors, the number is included. Okay, great. So when you add them up, then we get the same number, right? In the case of 18, if I add the numbers 1, 2, 3, and 6 and 9, I get a number which is much bigger than 18, right? And in some numbers, when we add, we get a smaller number. Let's take another example here. Let's say we want to find factors of, let's say, 12. So we are keeping the numbers small. Okay, great. So 1 time 12 is 12. Now, can you help me? Well, we know 2 times 6 is 12, and 3 times 4 is also 12. So 1, 2, 3, 4, 6, and 12 will become factors of number 12. For smaller numbers, this is a very good method. We can make set of numbers which when multiplied will give us the number itself. Great. Now let's move on and write these factors in different form. Now we are going to look into prime factorization. Now, prime factorization is a different concept where we are writing the number as a multiple of prime numbers. Now, before that, what are prime numbers? Well, prime numbers have exactly two factors. So let me write down prime numbers. Exactly two factors. Can you name some? Well, examples are numbers like 2, 3, 5, 7, 11. All these numbers are prime numbers, which we can list. And as an exercise, you can figure out how many prime numbers are there which are less than 100. It will be a neat exercise for you. Let me tell you, there are 25 prime numbers below 100 and 15 below 50. Okay, great. So that can be a good exercise for you. So these are the prime numbers. So what you notice is that every number, when you start dividing that number into smaller parts, will finally land up with prime numbers. I'll show you how. Okay, so let's take a number which is, say, 24. So we know 24 factors are, we can multiply, for example, 6 times 4 will give us 24. Now, 6 could be written as 2 times 3, right? And 4 can be written as 2 times 2. So you see, now further we cannot break down this tree. So we kind of made a tree where we landed up with all the factors. At the end, we have only the prime numbers, you see. And that is why this process is called prime factorization. So you notice that 24 can be written as product of these numbers. So I can write 24 as equal to 2 times, there are three 2's, right? So let me write them together, times 3. In exponent form, I can write 24 as 2 cubed, there are 3 of them, right? Times 3. You get the idea. So we have written 24 as 2 cubed times 3. So prime factorization of 24 can be written in the product form, which is 2 times 2 times 2 times 3, or we can short it out, writing in exponent form. Since there are three 2's, we'll write 2 cubed, 2 to the power of 3 times 3. So that is prime factorization, and we have written this in this particular form. Now the exercise for you is, if prime factorization of 24 is 2 cubed times 3, how many factors are there of 24? So find the number of factors. Find the number of factors of 24. Okay, so that is an exercise for you, right? Let me give you the answer right here. The number of factors will be, exponent of 2 is 3, and that of 3 is 1 if you don't write anything. So it'll be 4 times 2. It'll be 4 times 2. We multiply one more than the exponents for each prime factor, right? So it will be 8. So total will be 8, right? You can make a rainbow and check it out. But see, we got a formula here. This formula can help us find the number of factors from prime factorization. So that is a great work which we have achieved. Let's take up more examples, right? So if we take a bigger number, so let's say our number is, what should I write? Let's say 72. So we wrote a number 72, which is fairly big as compared to those which we had been working with so far. Okay, so let's do prime factorization. 72, let's divide by some number, right? 6, for example. So 6, 6 times 1 is 6, and then 12, 6 times 2, right? And now 6 can be written as 2 times 3, 12 can be written as 4 times 3, and 4 itself can be written as 2 times 2. So we can see that 72 can be written as what? 72 is equal to these prime numbers. So there are 1, 2, 3 twos. So write 2, 3 twos. So power of 3. Is it okay? 2 threes times 3 square. Right. So that makes it 72. Right. We would like to check it, correct? 2 times 2 is 4. 4 times 2 is 8. So if you say 8 times 3 square is 9, right? So 8 times 9 is 72. Perfect, perfect. So do you see how multiplying all the prime numbers which we get at the end, we do get the number itself, and that is the process of prime factorization. So from here, how do we find the number of factors? I gave you a formula earlier, right? So number of factors will be, let's say, number of factors will be how much? So if you see 2 cube, so we'll add 3 plus 1, right? So we'll add 1 power, and 3 square means 2 plus 1. Okay. So if I multiply 4 with 2 plus 1 is 3, there are in all 12 factors, right? But see, even without making the rainbow, we are able to find number of factors from prime factorization. That is the beauty of this process. Correct? Let's check. Now this time we are going to make a rainbow to check our answer. So 72 is equal to what? Well, in factored form, let me not write equal to. We'll write all the factors this time, making the rainbow, right? So 1 time 72 will always give us 72. Great. So that is one set. 2 times what? Half of 72 is 36, right? Great. So dividing by 3. So 3 times what? So 3 times 24 will give us 72, right? Great. We can also divide by 4, correct? So 4 times what is 72? So 4 times 1 and then 18, right? Okay. You can check. 4 times 18 will be 72. It can go by 6. Okay, 6 times what? 6 times 1 is 6, and then 12. So 6 times 2, right? So 12. Well, and there are more, right? Is there more? 8 times 9. So there is one more combination. So let me write down that also 8 times 9. Is that okay? Count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We do get 12 factors of 72, just as we had anticipated. You see that? So that is how factorization, prime factorization, writing it in power form and then finding factors work out. You get the whole idea, right? So neat exercise, right? So now here is something for you to do. Let's take up some numbers and practice finding prime factorization. Correct. So let's take a number which is a perfect square. For example, let's take 36 as our example. Okay. Can you do prime factorization of 36? Well, let's try it out. So 36 is 6 times 6, right? And 6 is 2 times 3, right? And therefore, we can write 36 as equal to what? 2 square, 2 times 2. times 3 squared. Is that clear to you? So we're done prime factorization of 36. Great. Let's take up another number. Let's say 125. So 125 can be divided into 5. So 5 times what? 5 times 25. And 25 can be written as 5 times 5. So 125 can be written as 5 times 5 times 5, right? Or we could write this as 5 cube. Makes sense, right? 5 cube. So now we got 36 and 125. Prime factorization is given to you. Can you write down number of factors for each? Well, once again, write it down and then check with my answer. So number of factors will be how many? So number of factors for each, right? Let's see, number of factors. Let me erase this and write 5q on the side. Do your calculations match the answer? Okay. So number of factors should be 2 square means 2 plus 1 will now be multiplied by 3 square, 2 plus 1. Power plus 1, right? So 3 times 3, we are expecting 9 factors in this case. You get the idea, right? How about 125? Since there is only 5 cube, there are only 4 factors. Okay. So in this case, 3 plus 1s are 4 factors, correct? You can check it out. For 125, we will have 4 factors, correct? You can list them out. For example, 125 is, of course, 1 into 25, correct? 1 into 125. That's one factor. And then 5 into 25. You see that? So these are the 4 factors of 125. You see how beautifully the rule works out, right? So I hope you have clear cut idea of how do we write factors, how do we write factors in exponent form once we do prime factorization, and from there, how do we find out the number of factors for that number, right? So let's get to another very beautiful question, and this is your test question, right? So we are doing something which is slightly different from what we did. So this time what I'm going to do is I'm going to write prime factorization of a number. Let's say the number is n and the prime factorization is 2 square times 3 cube times 5. So, if that is the prime factorization, my question is find n. Find the number n, right? And find number of factors. Okay, great. How will you do it? Take your time. I'm going to provide you the answer also in this particular case. Great. First thing is to find the number n. So for number n, let's multiply these numbers. 2 square, 2 times 2 is 4, right? 3 cube is 27. 5 number as such, correct? If you multiply these, you'll get a number, right? So basically 5 times 4 is 20, right? Times 27. So we get 1 0 and double 27, right? Double 27 will be 54. So the number here, n, is 540. Do you see that? How easily we have done the reverse calculation. So that's the beauty of math. We're just learning how do we work with numbers in different ways, right? 540 is this number for which prime factorization is 2 square times 3 cube times 5. Is that clear to you, right? Now, second part is find the number of factors. So let's find the number of factors. So number of factors will be how many, right? So number of factors will be this power 2 square, so we'll add 2 with 1, right? Multiply with 3 cube, 3 plus 1, 5, 1. So 1 plus 1, correct. Let's do it. So 3 times 4 times 2. Correct? 3 times 4 is 12, 12 times 2 is 24. So there will be in all 24 factors for a number n. You get it? Right? Clear? So that is how we do this particular case. So I hope you've understood the whole exercise of how do we factor to start with. What are factors, correct? How do we find all the factors of a number, making a rainbow? But if the number is very big and we want to find the number of factors, it becomes very difficult. So, what we do is prime factorization, and from prime factorization, easily we can find the number of factors. And this time, in the last example, we had the prime factorization. We did the reverse calculation of finding the number and then the number of factors. So, I hope with this you have a command on this particular topic of factorization, prime factorization, and relating that to the number of factors. So enjoy this journey of learning, and that is what we are bringing you to Inspired by Math for Junior Middle School Students. Book will be released in September. Thanks for watching and all the best.